Hey, welcome. We're about to dive into something that's, well, it's literally everything around us. But what's wild is that this everyday stuff holds some of the most extreme and bizarre secrets in the entire universe. Yep, we're talking about the states of matter. So, let me ask you something right off the bat. What in the world connects a diamond, a river, and the sun? I know, it sounds like a riddle, but it's not. The answer is matter. They're all made of the exact same basic stuff, just behaving in totally different ways. And trust me, by the end of this, you're going to see just how deep that connection really goes. All right, so here's the plan. We're going to start with what is matter. Then we'll cover the familiar stuff, solids, liquids, and gases. After that, we're going to check out the universe's favorite, plasma. Then we'll get really weird with colder than deep space. And finally, we'll wrap it all up with the 5 states of reality. It's going to be a wild ride for sure. All right, let's kick things off. Section 1. What is matter? Let's get to the bottom of the building blocks of everything. At its core, it's pretty simple. Matter is just the stuff that makes up the universe. Anything that has mass and takes up space. So the desk you're at, the water in your glass, even the air you're breathing right now, that's all matter. It's the physical substance of reality. But here's the big question, right? How does this one basic stuff create so many different things? Secret, the main point here, is that it all comes down to the tiny, tiny particles that everything's made of. And how they behave is based on just how they're arranged, how much energy they have, and the distance between them. That's it. That's the secret code that determines if something is solid, liquid, or something else entirely. Okay, let's put that secret code to the test. Section 2, solids, liquids, and gases. These are the 3 states we all experience every single day. Okay, first up, solids. Picture this. The particles are packed together super tightly in this really organized, rigid structure. They have so little energy that they can't really go anywhere. They're just kind of vibrating in place. Think of it like a packed dance floor where you can only jiggle around, and that's exactly why a solid, like say an ice cube, has a fixed shape and a fixed volume. Now, let's add a bit of energy. Let's turn up the heat on that ice cube. It melts, right? It becomes a liquid. The particles are still pretty close, but now they've got enough juice to break out of that rigid structure and start sliding past each other. The dance floor is a little less crowded now, so people can move around. And that's what allows a liquid to flow and take the shape of whatever container you put it in. And if you crank the heat up even more, whoosh, you get a gas. Now the particles have so much energy, they're just flying all over the place, totally free. The distance between them is massive, and they have almost no attraction to each other. It's like the dance is over and everyone is bouncing off the walls, filling the entire room. And that's exactly why a gas will always expand to fill any space you give it. And this is what I find so cool. This table really nails it, connecting how those particles behave to the properties we see in the real world. I mean, think about it. You can't really compress a solid, right? Well, that's because its particles are already jammed together. But a gas, you can compress that like crazy, because there's just so much empty space between its particles. It's a perfect illustration of how everything, from shape to density, comes right back to the energy and arrangement of those tiny building blocks. All right, so we've got solids, liquids, and gases down pat. We see them every day. But here's the thing that's going to blow your mind. Those 3 states, they make up less than 1% of all the visible matter in the universe. Yeah, you heard me right. So it's time to meet the real star of the show. And here it is, plasma, the 4th state. So imagine you take a gas and you just keep heating it to insane temperatures, thousands of degrees. The atoms get so unbelievably energized that their electrons are literally ripped right off. What you're left with is the superheated, electrically charged soup of particles. It's not a gas anymore. It's something new. And because it's made of all these charged particles, plasma does some incredible things. It's a fantastic conductor of electricity. Think about lightning bolts. That's plasma. It also gets pushed around by magnetic fields, which is how our sun, a giant ball of plasma, works. In fact, pretty much every star you see in the night sky is plasma. So you see, this isn't some exotic, rare thing. This is the universe's favorite state of matter. Okay, so we just went to the blistering heat of stars to find plasma. To find our 5th and final state, we have to go in the complete opposite direction. We're talking about the coldest temperatures physically possible in the universe. We're talking about getting just a tiny, tiny fraction of a degree above absolute zero. That's the point where all motion is supposed to stop. What you're looking at here is a Bose-Einstein Condensate, or a BEC for short. And let me tell you, this stuff is just weird, truly bizarre. Because when you get this cold, the normal rules of physics that we see every day, they just break. And the spooky, strange world of quantum mechanics completely takes over.
So what is a Bose-Einstein condensate? Well, when you chill certain types of atoms down this low, something incredible happens. They stop acting like individual particles. They get so close and have so little energy that they sort of merge. They lose their individual identities and start behaving as one single giant entity, a superatom. Imagine thousands of atoms all acting in perfect, synchronized harmony, like one giant quantum wave. It's a huge deal because it lets scientists see quantum weirdness on a scale they can actually study, which could lead to amazing things like quantum computers.
And this isn't just some crazy theory. As recently as 1995, scientists actually made one of these in a lab. They proved something that Bose and Einstein had predicted way, way back. And it was such a groundbreaking achievement, it won them the Nobel Prize. This is cutting-edge stuff. So let's recap our journey. We've seen 5 states of reality, from the rigid lockstep of a solid to the flowing dance of a liquid, the wild freedom of a gas, the supercharged energy of plasma, and finally, the bizarre quantum harmony of a Bose-Einstein condensate. And here's the main takeaway, the big idea. The world we see every day, the solids, liquids, and gases, that's just a tiny, tiny slice of what's really possible. Just by adding or taking away energy, the same fundamental building blocks of our universe can arrange themselves into forms that are totally predictable or so mind-bendingly strange they completely defy our common sense. And that leaves us with one final, pretty powerful thought. I mean, think about it. We've known about the first 3 states forever. We only really figured out plasma about 100 years ago. And the 5th state, we only confirmed it exists in 1995. It really makes you wonder, doesn't it? If we've only confirmed the 5th state in the last 30 years, what other states of reality are still out there, just waiting to be discovered?